Hi folks, we're going to take a look at question 21 from page 93, which is very similar to question 20, which was assigned for homework. Okay, so let's see what's going on here. So we have a polynomial that when it's divided by x minus 2 has a remainder of negative 5. Okay, now we can determine this remainder by dividing these by long division or by synthetic division, but we can also use the remainder theorem, which says that the remainder of this division is just the value of this expression at, in this case here, 2. Okay, so if we evaluate this expression at 2, the answer should be negative 5. And similarly, if we divide by x plus 1, the remainder is negative 16, meaning that if I evaluate this expression at negative 1, the answer should be negative 16. Okay, so the remainder theorem allows us to avoid doing the actual division if all we're looking for is the remainder. And they want us to determine the values of a and b. So anytime I'm looking for two unknowns, chances are I'm going to have to solve a system of equations in two unknowns. Okay, so let's move this over here. Okay, so here we've got this polynomial expression, and I'll give it a name here. I'm going to call this p at x just to help me write things out a little more easily. Okay, and it says that if I divide p at x by x minus 2, the remainder is equal to negative 5. Okay, so by the remainder theorem, this tells me that the function evaluated at 2. Now again, let's keep in mind that these linear factors are considered in the form x minus a. So in this case here, a is equal to 2. So if I evaluate this expression at 2, the answer should automatically give me the remainder, which is negative 5. Okay, but now I can just plug this into the equation. So we've got 2 cubed is 8, times 3 is 24. Okay, plus 2 squared, so plus 4a, then plus 2b, minus 9 has to be equal to negative 5. Okay, so if we simplify this here, we end up with 4a plus 2b equals, so here we've got negative 5 plus 9, so that's 4, and then we're subtracting the 24, so 4 minus 24 is negative 20. Okay, so here we see we have an equation in two unknowns, so not enough information to solve for a and b. We're going to need a second equation. Before I move on though, we can simplify this further because we see everything on both sides of the equation is divisible by 2, so I'll divide both sides of the equation by 2 to end up with 2a plus b equals negative 10. And I'll call this equation 1. Okay, now I do the same thing using the second piece of information that's given. So if I evaluate p at negative 1, the remainder is given by this expression and should be equal to negative 16. Okay, so same as before, I'm just going to plug this into the expression. So negative 1 cubed is still negative 1, so we end up with negative 3 plus negative 1 squared becomes positive, so plus a. Here x is going to be negative, so we're going to have minus b minus 9 is equal to negative 16. Okay, so if we clean this up a little, we have a minus b, and then here we have negative 3 minus 9 is negative 12. So we add 12 to the other side, we're going to be left with negative 4. Okay, and this will be my equation 2. So I'll put one over the other, as is often useful when we're solving a system of equations. Okay, and now I can solve this. Now this can be solved by substitution fairly easily because I have lots of coefficients at either 1 or minus 1, but I think it's much easier to just solve by elimination. So here, if I want to eliminate the b's, I just have to add the two equations. Okay, so 2a plus a is 3a, and then here the b's cancel each other out, and I'm just left with negative 10 plus minus 4, so negative 14. And so the a value is given by negative 14 over 3. So there's one of my answers. And now I can just substitute this back into either one of the equations to find the b value. So second one here looks easier. So I'm going to use equation 2. So I have a, which is negative 14 over 3, minus b is equal to negative 4. So I'll bring the b to the other side, and I'll bring the negative 4 here, so it'll become plus 4. And while I'm doing that, I'll right off the bat change it to fraction form. So this is something over 3 is going to be plus 12 over 3. Okay, and so solving that, b is equal to negative 14 plus 12, negative 2 over 3. Okay, so let's recap here. Is we use the fact that the remainder theorem allows us to determine a remainder when we divide by a linear factor without having to actually proceed with the division. Okay, and we were able to use that here to create two equations and solve a system of equations.